Hi, I'm Pete, and the theme of my I2K workshop is QuPath for Fiji users. Before I begin, I just want to mention that we're advertising positions, so if you'd like to join the QuPath team, I'll say a little bit more about that at the end. But the overview of my workshop is shown here. So my assumption is that if you're watching this, there's a strong chance that you know how to use ImageJ and Fiji fairly well. You might know a bit about QuPath, or you might be undecided as to whether it's worth getting to know. And so I'm going to begin by talking a little bit about why and when you might want to use QuPath, like the things it's good at, but also the things it is not so good at. And then I'll describe how you can use QuPath and ImageJ together, and then you can kind of get the best of both. And then after showing that for a little bit, I'm going to end by talking about what's coming next for the QuPath project and how you could get involved. So to begin, for anyone who doesn't know me at all, I wanted to point out that my background is in bioimage analysis. So I did my PhD working in retinal images, then I spent almost 3 years as a postdoc in Heidelberg as an image analyst at a core microscopy facility, and that's where I really got involved in ImageJ and Fiji. And after that, I did a postdoc as in digital pathology at Queen's University, and that was what led to me creating QuPath. And now I've ended up a senior lecturer at University of Edinburgh and building a group to try and bring all of these themes of my career together and to continue working on QuPath as well. And really, my experience of working in the microscopy facility is that bioimage analysis today depends upon a whole ecosystem of open source tools. And ImageJ and Fiji are really around the center of that, but there's other fantastic software as well, specialized in different areas. But the problem that I had whenever I started my postdoc in digital pathology is that none of these tools were designed for pathology, and they don't support the whole slide images that are found in pathology applications. And so, in case you're not familiar with them, a whole slide image is basically a high resolution scan of an entire glass slide. And so you could easily have 60 gigabytes of raw data if it was all uncompressed. But it's stored in the file in a tiled pyramidal format. So that means that the image is stored at multiple resolutions, broken into tiles. And so you need software which is designed to go into these files and pull out only the tiles that are relevant for visualization or for analysis at any particular moment. And ImageJ and Fiji weren't designed to do this, because, well, I guess whole slide scanners weren't such a big deal whenever they were first introduced. And so I couldn't work effectively with whole slide images in these software applications that I knew. And so that's what led to me creating QuPath to address this need. And so my idea for QuPath is that it would try and address the things that I couldn't do with ImageJ, Fiji, Python, Cell Profiler, or the other tools that I knew about. But it wouldn't try and reinvent the wheel. It would try and, build on the stuff that I've learned and adapt it to a new application, but also, as I was doing that, still keep in mind the kind of microscopy analysis problems that I worked on before that weren't solved quite as efficiently as I thought they maybe could be. So it gave me a platform to try and solve more problems than just for pathology, but that was certainly the focus when I was creating it. And so even today, if you are to take one of these whole slide images and drag it on top of Fiji, this is what you're likely to see. The bioformats importer will give you then lots of different, the individual pyramid levels as separate images. And if you select the low resolution pyramid level, it'll probably open, but you'll not get the full image. But if you select the highest resolution, then after a while, you're likely to see this error. And this error isn't really indicating that there's not a memory in your computer. It's indicating that the number of pixels in the image is exceeding the maximum array length in Java, or at least at some point you need an array which is longer than the maximum length supported by Java. And that's the reason why the image can't be opened. Regardless of whether you have much more RAM, it just simply can't be opened all in one go. On the other hand, if you're to drag the same image on top of QuPath, it should take a little while to read it, but then you're able to smoothly zoom in, zoom out the image, pan around and see the full resolution data. Because QuPath will still be using, well, bioformats or possibly OpenSlide, it's different libraries that QuPath can use, but it's only reading the pixels that it needs at any particular moment, and it's not reading the entire image, and that's why it doesn't need the very large array which was causing it to fail within Fiji. And so that was the initial problem that QuPath really solved, the ability to open and work with these whole slide images easily. It's now very widely used. It's not just for whole slide image analysis and pathology, and we'll see some other things that you can do with it in a moment. But if you look on the image.sc forum, there's over 2,000 discussions tagged with QuPath, so it's just behind ImageJ, Fiji and Cell Profiler, been around for much longer, so it's as new software, it is sort of growing very quickly. And so I think it's worth learning if you work on image analysis, because it's not too obscure at this stage. And it's been used in well over 1,000 papers, and that increases at about 1.7 or 1.8 per day, according to the stats I could figure out from Scopus. And so what you see here is a little 3-minute video that kind of gives an overview of kind of some of the stuff that QuPath can do, but we'll see more of it in detail in a moment. But it's quite good as an image viewer. It's good at stuff like image color transforms, like color deconvolution stuff is built in, particularly useful for pathology. It has this wands tool. You can see as I'm drawing, and the wands tool is magnification dependent. So as I zoom in, I can annotate smaller regions. If I could zoom out, I annotate larger regions. I've got tricks that I can prevent annotations from overlapping, and I can immediately use these annotations to train up a pixel classifier. Because QuPath is designed for multi-resolution images, I can train the classifier at different resolutions, and so I don't necessarily have to classify at the finest resolution, the highest detail, because that could be very slow. I can train lower resolution classifiers if needed. I can apply whatever classes I might need. I can use artificial neural networks, random trees, or whatever. This is based upon OpenCV's classifier implementations. Once I have these classifications, I can convert them into measurements, I can convert them into annotations, and then I can do further work within them. So all of this happens within the same software. But what I can also do is here I've opened a different image, and QuPath has some built-in algorithms, for example, for cell segmentation. So here I am selecting a moderately large region. So the whole image is maybe about 30 to 40 gigabytes uncompressed. So I'm selecting a relatively large region, and QuPath can then parallelize the application of its built-in cell detection algorithm. And furthermore, it can classify the cells as positive or negative based upon brown staining in this case. So it's key 67 we're looking at. But in addition to doing this detection, it can make about 44 different measurements of each cell, all happening in real time and within a matter of seconds. I can visualize these measurements in the form of measurement maps to get a sense of what they're doing. I can supplement the measurements. So here I'm creating a weighted average of the measurement for each cell and the neighboring cells. And then I can use all of this to train up an object classifier. So if I am to do a similar process as to what I did with the pixel classifier, I just draw a few annotations around different regions. And then if I go to train object classifier, live update, and I can interactively train an object classifier. And in this case, it'll retain the positive and negative classification I set before for the cells, but here it'll try and distinguish between tumor and non-tumor cells, because the output that you would normally want in this application is the percentage of tumor cells that's positive. And in addition, once you have all of that, you can do stuff like you can generate density maps to find like areas of a high density of cell, high density of tumor cells, high density of positive cells. You can find density based upon the numbers of cells locally or based upon the number of cells per unit area and so on. And so we have a very wide range of tools like this built into QuPath, all very flexible. But I guess you probably, if you're familiar with ImageJ and Fiji, you see the way QuPath approaches things is quite different. And it approaches from this sort of applications first angle. So whereas in QuPath, or in Fiji, you might possibly find a plugin that can do some detection analysis that's relevant to what you want. But if you're not relying upon that, then you're probably going to be taking your image, duplicating it, applying Gaussian filters, watershed transforms, all these kind of basic operations to detect what you want. Whereas in QuPath, lots of this is encapsulated into built-in commands, which is both a strength and a weakness. And so the ability to combine the two is very useful. One thing I would like to point out is that QuPath cell detection, which is a custom algorithm I developed for QuPath, originally started off is I created it as an ImageJ plugin. And so in the background, QuPath is using some ImageJ operations for, say, median filters and Gaussian filters and so on. So there's little bits of ImageJ happening in the background of QuPath here, but that's not true for all of QuPath's commands. Sometimes it will use OpenCV, sometimes it's a pure new implementation, sometimes it'll use Java topology suite and so on. So ImageJ is used in the background for some parts of QuPath, but they are still distinct software as well. Which brings us then to things that QuPath is not so good at. And one of them is custom pixel operations. So I said that if you're working with Fiji, you might duplicate an image, apply Gaussian filters, thresholds, and so on. That's actually really hard to do in QuPath. So if the existing cell segmentation works, or the super pixeling, or one of the other built-in commands, then it's great. You run the command, it's all very easy. If you want to do a very custom detection that QuPath doesn't support, that's actually much, much harder in QuPath than it is in ImageJ or Fiji, because QuPath is based upon the fundamental idea that it cannot guarantee that all of the pixels can be read at any one time. It can't guarantee that they will fit into RAM. And so you can't really do stuff like duplicate all the pixels of an image, because that's not going to work if you've got a 40 gigabyte image and you've 8 gigabytes of RAM. So QuPath is continually kind of working at the limits of the RAM that's available, and that fundamentally changes the way in which you have to work with it, as I'll show in a moment. QuPath is also not particularly good with ZSACs or time series. If you open a ZSAC or time series, you should see these little sliders that let you browse through, and so you can certainly work with them in QuPath, but all the analysis is still pretty 2D based, and so it's not particularly strong in those. From a programmer's perspective, the API is not particularly stable, at least certainly not as much as ImageJ, because it's a relatively new project. It was written as a postdoc originally under pressure to publish, and so now as I come back to it and sort of build it for the longer term, there's things that we need to change. There's bad design decisions that I made 4 or 5 years ago that we don't want to have to live with forever. And so the API is changing. It's not as stable as we would like, but it's getting there. It's improving. We now have Java docs online, but we don't have as much developer documentation as we like, and we don't have a very nice system for managing plugins and dependencies. Something like we'd love to have something like Fiji's updater, but unfortunately we don't have that. But hopefully from this you can see that QuPath has some strengths, but it has some weaknesses, and often they're kind of complementary with ImageJ and Fiji. So there's things that ImageJ and Fiji do much, much better that QuPath doesn't do. There's some things that QuPath do which are much harder, I would say, to do in ImageJ and Fiji. But obviously I'm biased in my assessment of all that anyway. But I mentioned that whenever you're using QuPath, you need to sort of change the way in which you think about your images and the way you approach analysis a little bit. And really the key thing that you need to know is that to use QuPath effectively, you need to convert your images into objects and then query the objects and work with those. And so an object is a bit like an ImageJ ROI, but it's actually more than an ImageJ ROI, as we'll see in a moment. But essentially you're starting off with the pixels of the image, but you spend as little time as possible working directly with the pixels, because what you're trying to do is to build up a kind of a model of the image contents. Like, here's an object that represents the tissue, here's an object that represents a vessel or a gland or whatever, and here's a million objects that represent individual cells. So all of that kind of stuff you can do in QuPath, but you're trying to generate these objects, and then once you have the objects, they're stored pretty efficiently and they can be queried. And so the big task of analysis is frequently then, how do you create these objects? And as we've seen, you can do it with built-in commands like cell detection. You can also do it with custom scripts, which we'll come to, or you can do it with pixel classification. But in addition, you can do it by running ImageJ commands and macros. And it's this ability to combine QuPath and ImageJ Fiji to get the best of both, which is sort of motivated making this the focus of my workshop. So what we're going to do now is I'm going to switch to give a live demo showing some of that in action. Okay, so what you can see here is QuPath. And I'll give you a little bit of an introduction to the software, but relating it back to how things work in ImageJ and Fiji. So because I really started out that I created this because I am such a big fan of ImageJ and Fiji, I might use them more or less interchangeably. So there's certainly a lot of inspiration there. One of them is I very much like the fact that I can open images by drag and drop. So lots of things you can do in QuPath simply by drag and drop. So here I dragged an image on top of QuPath. It brings up this dialog. Actually, in the next version, this dialog is going to be quite a lot prettier because QuPath needs to know the type of the image that you're working with, and I ask for that at an early stage. So in this case, I'm working with a bright field H&E. Normally, for pathology applications, you would choose, for a bright field, you would choose one of these two options, H&E or HTAB. If you have different stains, you can choose other. For fluorescence microscopy, you choose fluorescence. And if you're working with something like imaging mass cytometry, maybe fluorescence is close enough for QuPath's purposes. But you can choose other if you want. But if you get sick of seeing this dialog appear, it's always worth looking out for extra help around. So here we can see more details, and we can actually get QuPath to automatically estimate the image type. But it's good to know that it's setting the image type because we'll see in a moment that it matters. Because if I go to the brightness and contrast dialog, QuPath has color deconvolution built in. In Fiji, this is a separate command, and in QuPath, it's built in. So color deconvolution is essentially a way to computationally try and separate the stains in one of these bright field images. And that's why the image type matters, because if the image type was something different, so if I said HTAB, that's basically blue and brown, then QuPath will attempt color deconvolution, assuming that we have a brown stain that isn't there. And so if you want to do something like cell detection, which could incorporate a color deconvolution step, then if you have the wrong image type, then QuPath can be separating stains in the wrong way, and you get results which are kind of nonsense. And so that's why the image type is an important feature. Under this image tab, you can see all of the data is there, and you can double click on the type to change it if you need to, if it's not set properly at the stage when you import the image. And so this goes with the sort of QuPath's idea that it tries to streamline some parts of the analysis and tries to streamline particular common workflows. But it also tries to give you options that if it doesn't suit you, you don't have to do it. So that's why you have the different options for setting the image type automatically or not setting it, so you're not always plagued by this annoying dialog. So I'll switch back to original. This is the brightness and contrast. It works a little bit like ImageJ's min and max sliders, but you can also do it for the color deconvolve data. If I move my mouse over the image, I get to see the pixel values at the bottom right, and that also pays attention to what color transform I might have. And something that I should do when I'm here is I'll run this command show input display, so you'll see whenever I press shortcuts or mouse buttons, because there are lots of shortcuts within QuPath as well. One of them, for example, is I can do this color deconvolution by simply pressing a key for the channel that I want. And we'll see another time when that's useful later. But I don't want to spend too long just looking at this image because although you can open an image simply by drag and drop in QuPath, what you should normally do is you should actually create a project. Because rather than work with lots of individual images and so you have lots of individual data files, QuPath is a lot more effective if you store everything as a project and then it can manage your data files for you. So to create a project, it's simply a folder. And again, because I like drag and drop, if I drag an empty folder on, QuPath will ask, do I want to create a project for that? I'll say yes. I'll then drag a lot of images on, and then I will allow QuPath to import them. You can generally just accept the defaults here. But if you want, you can explore these options. You can actually choose what reader QuPath will use to open the image. So it can use bioformats. It can use ImageJ itself, which is good if you have an ImageJ TIFF, which can store like RAWs and extra information. You can use OpenSlide, which is another library for reading whole slide images. And JSON Server Builder is probably not going to help us here because it's quite QuPath specific. You can set the image type at this point if you want. And you can also request that the images import in a rotated way, which is useful if you have a 40 gigabyte whole slide image, which is just an orientation that is counterintuitive. You can have QuPath dynamically rotate it during import. But for now, we'll just accept the defaults. I'll press import. QuPath will try and figure out which library is able to open each of the images. And it will apply the import, and then our images will appear then in this left panel. And I can double click on any of them to open them. And then we can start to play around. Some of them may look familiar from the sample images of ImageJ. So for example, mitosis, it's a 5-dimensional image, and I can switch between them. One thing that I'm just going to mention now, because otherwise I might forget, is if you have a multi-channel image, the brightness and contrast, now we don't have the image type setting stains like H&E or HTAB. We simply get the channels, but the brightness and contrast allows us to toggle channels on or off. And again, pressing a number key will toggle the channel on or off. So this is one of the things that QuPath is quite useful for, is working with images with lots of channels. So you can work with an image easily up to about 40 channels or so, and visualize them and toggle channels on or off quite easily. So this is, the brightness and contrast dialog is also somewhat like ImageJ's channels tool. And there is a new setting which will allow you to adjust this even further in the next version of the software. So I'm using 0.3 at the moment, but 0.4 will have some extra features in this regard. Okay, and one other thing that I want to mention, just focusing still on the visualization side, is that we have in QuPath also this idea of a mini viewer. So a mini viewer can give you an enlarged view of the image that follows the mouse cursor. But a more interesting mini viewer in the context of multiplexed images or multi-channel images is the channel viewer, which essentially gives you a separate little mini viewer for each individual channel. And that can be really helpful if you're trying to make sense of a complex image with complex staining patterns. So I can adjust the brightness and contrast, and that will be reflected in the mini viewer as well. But this means that if I'm wanting to determine is the cell positive for various different markers, I can then put my cursor over it. And I don't have the same confusion that I'm always looking at one channel or I'm looking at a composite. I can then combine, I compare the information a lot more easily by seeing them all simultaneously. Okay. And so as you use QuPath more, you might find there's lots of little tricks and things hidden inside it that can be quite useful. Okay. So I'm going to switch to another image then. And I mentioned in the introduction that QuPath is quite strong on its annotation tools. They are here at the top. We have stuff like rectangle tool, and automatically whenever you draw an annotation in QuPath, you don't necessarily have a single row. It operates a little bit more like you're immediately adding it to an ImageJ or Fiji overlay. So I can create the region, I can move it around, create another region, I can click and I can move it around. And the way in which that works is that this tool, the so-called move tool, is the one that you want to have active most of the time, because it is the one that will allow me to move a region around, but it will also allow me to move myself around the image, depending upon where I click. So the selected region of interest is shown here in yellow with the handles at the side. And if I click inside a selected region of interest, I can move that with the move tool. If I select outside, I can move around the image instead. And I can double click to select an annotation. And I can press backspace to delete the annotations if I want. And so typically, whenever you select a tool in QuPath, it will automatically switch back to the move tool after you've drawn something. You can change that in the preferences if you want. Here are the preferences. And while ImageJ has some preferences and some different menus, they're all combined here in QuPath, mostly in this one place. So here, okay, we have an image. I have drawn a region. I can double click to select an area. I can double click to remove it. I can click on this annotations tab, and that will then show me all of the annotations I've got. And I have shortcuts for all of these, and they tend to be fairly intuitive. So R for rectangle. This could be a circle, could be an ellipse. easier to just give it an O for the most circular letter is the shortcut, L for line, P for polygon, and so on. And so it doesn't quite have as many different drawing commands as ImageJ, but the commands that it has are quite flexible. So here, for example, I've drawn a rather complex polygon that it's not necessarily very clear what's inside and what's outside. If I want to see that, I just press Shift and F and that will fill in my polygon. And now I can see what's inside and what's outside. I can also draw a polygon by clicking and dragging, and then it acts, yeah, more like a regular, like polyline, or yeah, I can't remember what the name of that tool would be elsewhere. Or I can combine, so I can click for individual points, and then I can click and drag for a little bit, and then individual points and double click to end. And so ImageJ has got some different tools depending upon how you want to do it, and QuPath sort of wraps some of them up together. And as I do these, I immediately get the area and perimeter measurements, and sometimes some other measurements calculated by default. So in ImageJ, you would create your regions of interest and then measure them and then generate a results table. In QuPath, all of this is joined together, and you can visualize the results here under this annotation tab. But what you also might want to do then is calculate or determine more complex ROIs. And here we have a brush tool, which is particularly useful, I think, because the brush tool is zoom dependent. So if I want to brush a large region, I just zoom out, small region, zoom in. And if I want the brush to become an eraser, I hold down the Alt key. And then suddenly my brush is an eraser. And so this gives the option of, and the brush doesn't switch back to the move tool afterwards, I should point out, because you normally want to not have to keep the mouse down the whole time. So we have the option here of annotating some pretty complex regions pretty quickly, but we can improve that even further by switching to the wands tool. So the shortcut, W for wand or B for brush. And this uses some intensity information from the image in order to be able to create regions quite quickly. But again, this is zoom dependent. So if I want to annotate a very small region, I just zoom in and use the wand. If I want to remove, I hold down the Alt key. And again, I can do that using the wand. And so I can remove regions, yeah, again, using the intensity information, or I can switch to use the brush and then I get full control. And so I can switch between the brush and the wand, holding down Alt, not holding down Alt, to annotate regions quite quickly and quite nicely. I can also, if I annotate a region I don't want it to overlap, I can hold down Command and Shift or Control and Shift, and then that will automatically constrain QuPath to not overlap the regions. If I don't want to edit an annotation, I can then right click and I can say that I want to lock it. And then that will allow me to draw a new region inside, and this time Control and Shift will constrain the annotation to prevent it from going outside. And so there's these various different annotation tricks. I think the most comprehensive list of them with videos is in, actually on Twitter, I posted some time ago. But yeah, we have these options which can make QuPath quite good as an annotation tool. One other thing that I should say as I do it is that as you annotate these, you can assign a classification. This is not a very meaningful classification, so forgive me for that. But then the color of the annotation is going to be based upon the classification that you set, and that can allow you to separate between annotations. You can set classifications in here, you can set classifications by right click, or there's even another trick. If I shift right click, I can select them from this little list. And so we can add in additional information along with our annotations. And so it's all very nice if you want to use QuPath in general, but what if you want to do most of your analysis in ImageJ or Fiji, but you still quite like QuPath's annotation tools? Well, in that case, you're in luck, because we can then send the annotations to Fiji, or to ImageJ rather. So I said that QuPath uses ImageJ sometimes in the background for certain commands. And that means that it has ImageJ sort of embedded, so the IJ jar is included in the QuPath distribution, and I can take advantage of that. So if I've drawn this region, the entire image itself, in this case, it's relatively small, 6.6 gigabytes, but it's still too big to open in one go in ImageJ. But I can draw a region, and then I can say that I want to send this region to ImageJ, and I can say that I want to include the ROI. And so QuPath will launch an ImageJ instance, and it will convert its own ROI into an ImageJ representation. And so QuPath doesn't use ImageJ ROIs internally. The reason for that is for efficiency, because the ImageJ ROIs have quite a lot of extra properties and colors and names and all that kind of stuff. And QuPath is designed to be able to handle having potentially 1 million cells or several million objects across the image. And so it has its own ROI representation, but it can convert them to an ImageJ representation if it needs to, and then send that off to ImageJ. And so that means that we can then start to combine the applications together. I wasn't able to open this entire image in ImageJ, but with QuPath, I can select a region. I can then send the pixels from that region to ImageJ. And if necessary, I can also send the annotation that I've drawn as an ImageJ ROI. But what if I want to send the entire image to ImageJ? I can do that as well. If I say send region to ImageJ, if I choose a resolution of 1, I am riskily going to do it. It's going to say, yeah, it's too large to extract, because QuPath calculates that this is not going to work in ImageJ. But what I can then do is I can change the resolution. And so let's say I want to downsample it by a factor of 100. So it's going to make a much smaller version of the image. That's what I can do here. The resolution is 100, and that is in the units of downsampling. So basically I'm dividing the width and height by 100 each. I can also specify the resolution in terms of microns. So I would say I'd like to send an image at 4 microns per pixel or something. We'll do that in a moment. For now, I'm going to downsample by a factor of 100. I will send that to ImageJ, and we get this small version of the image. But what's important to know about that is that QuPath is trying to pay attention to what it's sending to ImageJ, and it's going to try and fix anything that it needs to. So here we can see the pixel width and the height of the full resolution image in QuPath is about 0.5. Within ImageJ, it will then multiply that by 100, because it will take into consideration the downsampling that we are actually applying there. Furthermore, what we can do is, let's say I want to just select one area, and I want to send it to ImageJ, and this time I'm going to specify that I want it to be 10 microns per pixel, and I'll send it to ImageJ here. Now I have the image properties. They've been set. QuPath has figured out how to resize it. It's set the image properties so that it does correspond with about 10 microns per pixel, but it's also set the origin of the region that I've sent to ImageJ. And that turns out to be quite important, because if I am to then start to do some ImageJ processing, so for example, I want to apply a large Gaussian filter, threshold a region, create selection, and then if I want to get this somehow back into QuPath, the ImageJ instance that QuPath starts has a custom command which allows it to send back regions. And so it uses all of this information from the image properties, the pixel size, the origin, to figure out what the scaling should be. So it's able to then send back the region and to adjust it accordingly. And so you can see it's a little bit pixelated because it was calculated from ImageJ's low resolution version of the image. But QuPath is able to figure out what scaling, translation, and so on it needs in order to be able to get that back to the right location within the image. And so that's a way in which you can use QuPath and ImageJ together. ImageJ wouldn't be able to handle the whole slide image directly, but you can certainly apply a lot of meaningful ImageJ analysis on smaller regions. And then QuPath allows you to select those regions interactively, send them off to ImageJ, do your processing, and then get the regions back to visualize on the whole slide image context afterwards. What you can also do is that you can say, for example, apply color deconvolution here to separate a region, send it to ImageJ, and if I choose apply color transforms, then it will send the transformed version of the image to ImageJ at the resolution I wanted. So here it's applying the color deconvolution as I go. And so again, that's using some of QuPath's features and making them interact nicely with ImageJ. What if then we wanted to go a little bit further than that? So for example, if we wanted to create a macro, for example. So I will send a region to ImageJ, I will downsample by a lot. I'll not bother the color transforms, not bother sending the ROI. It sends it to ImageJ, then I can run the macro recorder. Let's say I want to make the image 8 bits. I want to do a little bit of Gaussian filtering. Oops. And I will apply a threshold then. And I will create a selection and I will send the ROI to QuPath. So all of this is stored in ImageJ's macro recorder. I can generate a macro from it. I will then save that on my desktop. And now if I am to open a different image from the project, I can go over, I can drag and drop the macro on top of QuPath. Oops. And because I've got two monitors open at the minute, the resolution got a little bit confused, but here we are back on the right screen. So when I drag and drop the macro on top of QuPath, it opens up the macro runner. What I do need to remember is that I need to adjust the downsampling factors. So I need to adjust the resolution of the image that I'm sending to ImageJ. But if I do that, I can select a region that I want to process. I'll say I want to get the objects as annotations. I'll explain that in a moment. I'll say run. Oops. And what we can find is that it's not necessarily the most beautiful of results because the threshold applied to this image is considerably less successful than the other image, but it has been able to apply these steps. Actually, what I shouldn't have is this line in my macro, and I shouldn't have open in the macro because I ran that by accident. So let's remove that. Press run. Considerably better, I think, because I had accidentally included a macro which set a ROI that had messed with my threshold. So actually, that is much better. Because it's been a while since I used ImageJ macros, forgot that I need to edit what's been recorded. But yeah, so hopefully that gives a feeling of then some of the stuff that you can do in making ImageJ and QuPath talk to one another. What if you were to want to do a little bit more than that? So for example, if I am to take a region, and I will actually close ImageJ down now, and I can run, say, QuPath cell detection. So the same way as you can bring up a command list in ImageJ with Control and L, or just by pressing L, you can bring up a command list in QuPath by pressing Control and L, because I wanted to make it easy to learn for somebody who's familiar with ImageJ. So here, if I'm going to say I want to, oops, no, that's not the command that I wanted, cell detection, that's the one I wanted. If I press run, this will apply QuPath cell detection. Take a little bit of time. Okay, and within that time it has detected almost 9,000 cells. So each one of these cells is a QuPath object. Oops, that was unfortunate. Each one of these is QuPath object. I can double click to select it and I get all the measurements for that object. And from QuPath's perspective, the annotation that I drew and the cells that I detected are different things. The cells are detections, and I toggle them on and off by pressing this button. The tooltip says show detections. The annotations are something slightly different. I toggle them on and off with this button called annotations. And the reason for that is that the annotations are designed to be flexible. So you can edit them, you can do more stuff with them, but they're not stored as efficiently as detections are. So essentially when you're working with QuPath, you have the choice as to, whenever you create an object to represent something, you have to decide, should it be an annotation in which case you're prioritizing flexibility. You might have maybe 100 annotations in an image, that's fine. Maybe even 1,000 would be okay. But yeah, they basically, your annotation objects in QuPath define larger regions of interest. Your detection objects, on the other hand, are intended for things that you could have thousands of or millions of even, like cells, for example. But you can edit these further, or at least not without a lot of scripting. And so this is a slightly more developed concept beyond ImageJ's ROIs, where you have a ROI, and if you start to create a ROI manager and have 1 million ROIs in it, performance is going to suffer a lot. QuPath can handle large numbers of objects as long as they are detections, and it can handle hundreds or maybe a couple of thousands of annotations as well. And so you have to sort of combine these together and figure out which ones you want. You can have classifications for each of them. So as again, I showed in the video before, ignore the fact that I'm choosing meaningless classes here. I can classify all of my detections using object classifier. And so the objects I created in QuPath and the detections that I've got here, they all have classifications associated with them as well, classifications and measurements. So this is, you can see that an object in QuPath has a little bit more to it than an ImageJ ROI, but an ImageJ ROI is really its closest counterpart. But if I want, I can send all of that to ImageJ as well. So let's say I want to send this region to ImageJ. If I choose to include the overlay, and I'm going to say, I'm going to risk sending this at the full resolution. No, 1 micron. Okay, it's going to downsample it a little bit. I'm going to say OK. And it is then sending everything that I detected in QuPath to ImageJ as well as it can. And so all of these, the cells have to end up being split into 2 ROIs, and they're added to the ImageJ overlay, but it will preserve the colors as they were displayed in QuPath. We can do stuff with ImageJ, like we can send to the ROI manager. You can see that the names represent the classes. And so QuPath tries to preserve as much information as it can whenever it sends a part of an image to ImageJ. And so again, if you want to do some initial steps of your analysis in QuPath, but then get your data into ImageJ because you're more comfortable there working afterwards, this is one way to do it. What I should also say is that what if you would like, ideally, to be able to work in Fiji as opposed to ImageJ? Well, in this case, QuPath is only embedding ImageJ itself, so it's not embedding Fiji. You can, however, take advantage of the fact that whenever you save an ImageJ TIFF, then if I open up Fiji, the ImageJ TIFF, if I've done this right, should have preserved the overlay. And it should have preserved the properties. So here I open it in Fiji. So I still have all the objects, and now I have access to all of the Fiji commands that I might want. And it's 1 microns per pixel. Possibly a bad choice because it looks like the image isn't calibrated, but you can see it is microns. That is the resolution that we sent it at, and the origin is still there. And that can be useful if you want to then start to combine a little bit of Fiji analysis or some Fiji steps. So in this case, I'm not going to do anything terribly sophisticated, but I could have done this perfectly well in ImageJ itself, but I'm going into Fiji. I am then going to analyze particles, add to an overlay again. And effectively here, I have done a bit of analysis in Fiji. And again, now I'm going to take advantage of the fact that an ImageJ TIFF will preserve all of that information. Now, if I open up ImageJ from within QuPath and I open up my Fiji image, let's just delete everything here so we don't get too confused. Then I can then send the overlay to QuPath as whatever sort of object I might want. And because all of the information has been preserved about the resolution, the origin, and so on, I can get information from QuPath to ImageJ, and then from ImageJ to Fiji, do some further analysis and bring it back. It is a little bit awkward, I admit that. But one thing that might be able to help you is, depending upon what exactly you want to do in Fiji, we have the option within QuPath of going to the extensions menu, setting the plugins directory, and if I am to go to Fiji on a Mac, I need to right click and say show package contents, drag over the plugins directory, then that means not very much until I restart QuPath. But when I do restart QuPath, what I should find is that the ImageJ instance that I have, so I'll just say send snapshot to ImageJ, which is just a screenshot of what's in the viewer, is now going to try and read the plugins from Fiji. This doesn't work perfectly because there's lots of other magic going on in Fiji that isn't very compatible with QuPath, because QuPath has conflicting dependencies and QuPath needs Java 11 and so on. So not every plugin is going to work if you do this, but some plugins will work. And so it brings the embedded ImageJ within QuPath a little bit closer to Fiji. Or alternatively, you can set, again, here you can go to extensions, set plugins directory, set it to another ImageJ installation on your computer to access your local ImageJ plugins. So you can set it to any ImageJ installation and it should be able to find the plugins. If that installation happens to be a Fiji distribution, not everything's going to work, but some of the plugins will work. So for example, if I select a region here, I am going to take a risk that color deconvolution might work. As you all remember, we already have color deconvolution within QuPath anyway, so we don't need it. But if we are to run the color deconvolution plugin in Fiji, we could do that because we set the plugin directory to be Fiji's. So certainly the simpler plugins that you can find within Fiji should work this way. So to recap then, QuPath, basically it has its own way of representing things. It has its own object concept, which doesn't quite map to ImageJ's ROIs. It's a bit more extensive than ImageJ's ROIs. It has more options associated with it, but we can send the information to ImageJ if we need to, and it will convert it to the closest form that it can. And then we can do further analysis in Fiji, and we can send the regions of interest that we generate in Fiji back into QuPath. And so there's a bit more explanation about this in the documentation as well. One other thing that I want to say just when I'm here is an additional feature of detections and annotations and them being different is that if I run cell detection within QuPath, again, positive cell detection here, so I'm getting lots of detections and a small number of annotations. I mentioned the distinction of being one of efficiency, that you can turn them on and off independently. But you can also get different measurement tables. So whereas in ImageJ you typically have one results table, in QuPath you can have different measurement tables depending on the objects that you've got. So we can have an annotation measurements table, which we only have one annotation here. Hang on, I will draw two more. So now annotation measurements, we get our 3 annotations. Or I can also separately have a detection measurement table, which will give us the measurements for all of the individual cells. And so we have that distinction that we can make, which can be quite handy. And these tables we can sort by column, we can visualize histograms, and so on if we need to. And so this is a little bit like ImageJ's results table, but there is this distinction between the different types of objects that you might have. Okay, so what else do I want to tell you about this? So I think the last thing then, or almost the last thing, is as the counterpart to ImageJ's macro recorder, QuPath has a workflow tab, but it's always on, so you don't need to press to record the macro. It will record key steps. It won't record everything. So if I draw a region of interest, it won't record that because it's very image specific. But it will record setting the image type. It'll record setting the color deconvolution stains and the positive cell detection that we ran in here. It'll record the parameters. If I double click, it brings up the dialog with the same parameters. Or if I choose create script, it will create then a script here that I can then run to apply the same sort of analysis again. And so this operates a little bit like ImageJ's macro recorder, but it is always on and it will save the steps within the data file. Which brings us then to the management of all of this data. So QuPath doesn't ever duplicate the image to the project. Rather, it uses this folder that we created, creates a data folder inside it, and this as well. So this is basically a list of paths to the images and identifiers for them. Then the data folder contains a thumbnail for each image, which is what's displayed here, but it doesn't duplicate the original image file. But if then I am to save this, then what we can find is that for this particular image, which happens to have ID of 3, then we get more than the thumbnail, we get a little summary, and we get this data file, which is actually Java serialized data, which means that if I open another image, if I go back to this one, I should find the objects and everything still there. And so QuPath takes care of that for you, that you don't have to save lots of data files separately, just create a project and then work with it in there. If you ever want to check the data file, back it up, the easiest thing is to simply zip your project or create a duplicate of that, because everything should be encapsulated inside. So hopefully that becomes a useful way to look after and manage your data. I mentioned the workflow tab that we can create a script from. Then taking advantage of this project thing, we have the ability to run batch processing as you can in ImageJ, but in this case what you do is choose run for project, choose your images, move them across here and press OK, and then QuPath will automatically create all of the loops that it needs to go through all of the images and run the processing steps. I can show that in action with a example script. So for example here, if I say image data equals get current image data, so that is going to be whatever image is open at the current time. If I just then print that, so this is using the Groovy programming language, this is what we get. And if I go run for project, and I'm going to say without save because I don't want it to save a data file each time I do this, bring this across, then QuPath will automatically open each of the images in turn and then print out the data for that image as it goes. And so that's the way in which you'd apply batch processing. And so I guess you can probably see that lots of this stuff has similarities to ImageJ, or you can do some of the similar things because I was very much inspired by ImageJ, but there's aspects of it which are perhaps a bit more streamlined in QuPath, but on the other side, also perhaps a bit less flexible in QuPath. And so it's not the case that QuPath in any way tries to replace it, but having access to both and knowing when it makes sense to use one software or the other can be quite useful, because even though I wrote QuPath, I still use ImageJ and Fiji myself a lot. Okay. And the last thing that I want to say about this is I will very, very briefly, and possibly regrettably if this becomes too complicated, try to explain a little bit of QuPath's API. So basically QuPath from a programmer, scripter's perspective in a way that relates to ImageJ. And so very, very briefly, and this should be better documented online. If it's not, you can always ask on the forum. Let's suppose that I wanted to create this, select this region and do a little bit of processing within ImageJ. So I want to basically get these pixels and programmatically convert them into an ImageJ form. So feel free to skip this if you don't do any ImageJ scripting, because it's not going to make an awful lot of sense. But if you do ImageJ scripting, then hopefully this could be useful for you. So I'll open up the script editor. And what I would do in QuPath is I would start off by getting the image data, which is basically everything associated with this image. And the key thing in QuPath, which is able to return pixels for me, is the image server. So I say image server equals image data get server. And if I'm not sure what I can do with something, I can say println describe server. And this will basically give me a list of methods available on an image server. One of the key ones for us here is read buffered image, which is the thing which is going to be able to return the pixels for the region that I've selected. And that needs a region request. So what I can then do, I think, is println region request to get an idea what that might look like. And that has a create instance method, which is the one that we want here. So this should be a little bit better documented online, but essentially if we want to get our pixels, we go for request equals region request create instance server get path, which is the path to the image, the downsample factor, so how much we want to scale it down, let's say 10, and let's say we want to do it for the current ROI. So I'll say ROI equals get selected ROI. So this is a similar sort of idea to ImageJ's macro language. It's not quite the same. It's actually using the full groovy programming language, but it's using lots of static imports from the classes QP and QPEX. So these static imports basically mean that you've got access to methods that you can call directly. So it feels a bit like a micro language, even though it isn't. So println request. This is basically the object that QuPath uses to encapsulate that these are the pixels that we want. So image equals server read buffered image request println image, because I want to check what I've got, and that has extracted then the pixels that I might care about having. So if you've done much Java programming working with images, you might recognize that buffered images is a built-in Java thing. It's not an ImageJ specific thing. So I need to convert it to an ImageJ specific thing. So I might say, for example, imp equals new IJ image plus some title image. And then I can say that I want to show it. That might work if I've got it right. Okay. So now we've been able to extract some pixels, get them into ImageJ and show it. I will send a snapshot because I want to, that didn't in itself launch the ImageJ GUI, and that's going to be helpful. Okay, if I do that, I've got some pixels, I've got them into ImageJ, and I could potentially do some processing or something here if I wanted to. The trouble is, if we do it this way, we've lost all of the important calibration information that we potentially wanted to have. And so fortunately, QuPath has some helpful commands that can handle that for us. And they are encapsulated in the class IJTools. So for IJTools for ImageJ tools. So if I run that, these are all the methods that I could want. And the one that I care about here is convert to image plus. And you notice that it returns a path image, which is a slightly awkward construct that we will come to in a moment. But you basically call get image on it and you get an image plus. So imp equals IJTools convert to image plus request. Oh, sorry, I need to give it the server request and get image. And now if I say imp show at the end, what we should find is that we now have an image plus, which is properly calibrated. All the pixel size have been updated, the origin has been set, and this is similar to as if we had extracted the region this way. And so effectively we have the option to then do any kind of groovy scripting here that we could do with a regular ImageJ through Fiji Script Editor. Again, we don't have access to all of Fiji stuff, so we don't have all of the nice or parameter stuff available through Fiji and ImageJ too, but we have the basic scripting and the ability to create ImageJ or ImageJ-like structures. And if you want to find out more about that, then IJ Tools is the place to go. I should put a link to the Java docs below, but when you're too lazy to look for the Java docs, as I often am, print line describe, and then the class that you care about will give you all of the static methods you might want to call on it, and that can help. So apologies if that was more information than you may have wanted, but it just shows a little bit of, if you want to approach this from a programming perspective or a scripting perspective, how you can start to create the connections between QuPath and ImageJ as well. Okay, so switching back then to the presentation, to summarize then what I showed is I want to speak a little bit about how QuPath differs from ImageJ, and one of the things is that QuPath is really focused on applications. So I hope I'm being fair to ImageJ and Fiji, but my impression of them is that they are incredibly general, and we absolutely need tools that are incredibly general like that. But if you want to do specific things, it's often quite difficult. You need to get a custom plugin. If you want to do something like cell detection, you probably need to find a custom plugin, or you need to get into the details of individual operations. QuPath tries to approach that differently, and so it has a cell detection, which it's not going to work on every image, but it's pretty flexible. It works on bright field fluorescence, different staining types, and so on. And so if you have an application that fits with something that QuPath supports, with its cell detection, classification, and so on, it should be pretty streamlined. And the goal is that QuPath focuses on streamlining these common applications that lots of people need to do, and over time broadens out to support a wider range of applications. Whereas I think in ImageJ and Fiji, it's a little bit more the opposite direction, is that the platform itself is incredibly broad, incredibly powerful in general. But if you want to solve a problem for a specific application, then you need to add individual plugins for that. And so it's just a different kind of approach. And one of the reasons for that is that in creating QuPath, there was no point whatsoever in replicating what ImageJ Fiji already did so well. QuPath is also mostly 2D, but the hard 2D stuff, it handles whole slide images and multiplexed images with lots of channels. And it does, to some extent, handle Z stacks and time series, but it's certainly not as strong on that as Fiji. Images are managed in projects, and so you don't need to save individual data files like ROI sets and stuff like that. And all of the stuff is encapsulated together within that. It's object-based, where an object has a type, which could be a detection or annotations. It has a ROI, it has a classification, and it has a measurement list, which we saw some examples of there. And there's also the ability in QuPath to dynamically generate measurements, and that's why if we draw an annotation with positive and negative cells inside, QuPath will dynamically give you the percentage of positive cells, the number of positive cells per millimeter squared, and that kind of thing. But the objects themselves have measurement lists, and in addition you get dynamic measurements too. And if you're able to generate objects in your image, you can query them quite easily. But what you cannot do very easily in QuPath is you can't change pixel values. And so if you find that you're working on an application where the built-in stuff in QuPath isn't able to detect what you want, you can't use the cell detection, you can't use the super pixels, you can't use the pixel classifier and so on, then you really need to get into some deeper scripting or start to rely upon sending areas to ImageJ, or generate your ROIs in Fiji and then import them into QuPath, because changing pixel values isn't something that QuPath really does. It's also, if you want to normalize your image, that's probably something you want to do outside of QuPath, and then just import the normalized image afterwards. And so, yeah, in no way does QuPath replace Fiji, and having skills in both can be beneficial. It might help to know that QuPath's aims are, well, I suppose my aims, because QuPath doesn't really have thoughts of its own, but my aims are that it should be open. The analysis, I think, should be transparent and verifiable. So that's why a lot of work's gone into the visualization tools. They build it to like color code measurements, and all of that is built in. Because I want the people who are using it, often they're domain experts. They really understand the images and the data. They don't necessarily have to understand the details of the analysis, although it certainly helps if they do, and we'll come to that in a second. But they do need to know what has been measured, what has been detected and quantified, and so on. And so the software tries to make that as open as possible, and is also open in the sense of the source code is available. It is open source. It tries to be flexible, and so if it's possible to solve a single problem really well, then it's worth doing it, because that can then be applied to lots of different applications. And so stuff like QuPath cell detection works across a wide range of images, although not all of them. But the software itself is designed in such a way that if you have a better way of detecting cells, you can slot it in through a script or an extension, and then you can still use everything else. You can still use the pixel object classifiers, measurements, and so on. And so it tries to give you these like atomic parts that can be pieced together to solve different things. And it tries to be user-friendly, because I think the hard part of analysis should be defining the scientific question that you want to answer, and you shouldn't have to wrestle it out of the software. And these are basically in order of priority. I know there's room for improvement in all of these, and in particular QuPath is very user-friendly for some things, not particularly user-friendly for others. But really, flexibility and user-friendliness are sometimes hard to reconcile with one another. And in this case, I think flexibility has been a slightly higher priority. But yeah, QuPath is trying to optimize all three of them in one way or another. And although I said that the intention is that the domain experts don't normally or don't always have to get into the details of what the image analysis is doing, in terms of maybe understanding the code or being able to code up the algorithms themselves, I still think that they should know really what it's doing from the perspective of what parameters they might need to tweak, where the potential biases are, and so on. And so it really helps to understand some image analysis concepts. And so if you'll let me, I would like to just briefly mention this side project that I had, which is now available, which is an open handbook that aims to explain image analysis concepts. It's written as a Jupyter book, which means it can be interactive, and so I've embedded various videos from teaching that I've done over the years. And it tries to be software agnostic, but if it's based on anything, it's more based upon ImageJ, Fiji, and Python than QuPath. So QuPath gets mentioned, but I don't think QuPath is the place to go to learn the concepts. I think ImageJ is much better for that. And so within the software, within this book, you'll find key concepts explained, but also how they are implemented with ImageJ. So I've described, for example, some of the details of how these things work and things to look out for, like errors that might creep in if you don't know that the software is doing certain things. And so I hope to be able to extend this to include more of QuPath at some point, but at the minute it's focusing more on ImageJ and Python. There's quizzes embedded, so you can get questions and answers. And then we have, well, thanks to the fantastic ImageJ.js project, you can even apply some practicals launching a JavaScript version of ImageJ directly from the browser. And because it's a Jupyter book, you can actually visualize the code used to generate all of the almost all of the figures. You can turn it into live code. You can modify them if you want to create slightly different figures and so on. And so I guess one of the reasons I mention this is that from my perspective, even though I work in QuPath and all of that, I think you should use the software that's best for the job that you want to do. And so I don't think QuPath is the thing to teach these concepts, so I went to ImageJ and Fiji. And I think fundamental to how QuPath is or should be developed is it should focus on problems that are on needs that aren't being met by other software. And so that's what I try to do with it. And so I hope that this workshop is useful in showing how QuPath can be a beneficial skill alongside something else which has been very well established. And so as I'm building a research script now, the software itself will be driven by research projects and unmet needs, and lots of these come up in the forum, the Scientific Community Image Forum, so it's a great place to go and discuss it. I think QuPath also has a little bit of an interest, because it has a connection to pathology as well, it brings it a little bit into clinical applications, including veterinary applications as well. And so it has some use probably where ImageJ is maybe not quite so widely used. And as it continues to be developed then, initially it started off, it was me, and then I was in industry, so it was no one for a while. And then I left because I wanted to do open source work again, spent a bit of time figuring out what to do, joined the University of Edinburgh as a senior lecturer then in 2018. I've been rebuilding the project since then. And we had a little bit of funding and some from the Chan Zuckerberg initiative in the first cycle of the Essential Open Source Software for Science, which enabled Melvin to stay working on the project with me. And so that's really helped over the last few years. And fortunately, the QuPath has been funded again. And so this means that 2 positions are currently being advertised to address some of these limitations that I mentioned before, like the API is not as stable as it could be, the knowing how to script it is not as clear as it could be, and so on. So that's something that I hope to be able to improve. And if you would like to join me in improving that, please consider applying for these positions which are being advertised at the moment. In addition, there's been another bit of funding good news for over the next 5 years in terms of the Wellcome Trust Technology Development Grant, which is going to expand the algorithms in QuPath, improve the workflow development, validation and sharing, and extend it to new imaging modalities. So some of the weaknesses around, say, 3D images and so on, or being able to link different imaging types within the same platform. So these will be addressed by this. And so I just want to give you a little bit of preview of some of the other stuff that can be done or is on its way to being done with QuPath. Here I'm running Stardust cell segmentation through QuPath. I'm running a custom UNet through QuPath in order to get the epithelial segmentations of basically the green pixels here in the background. I can feed through the UNet classifications to the Stardust segmentations in order to be able to classify the nuclei and so on. And so we can start to make connections with these other really exciting tools being developed. And the aim of the grant is to try and streamline stuff. So for example, at the minute, if you want to apply some analysis in QuPath, you can run a script or you can repeat a lot of steps. But I want to be able to have, if you have a really solid workflow, I wanted to be able to sort of guide the user through it in a much easier to use way. And so here's a demo of that for special transcriptomics where I just prototyped a kind of a user interface in QuPath for that. And better support for multi-images, which can include multiplexed, multidimensional, and multimodal images. So what you can see here is an example image where we already have quite a lot of steps there. So we have the ability to support an 8-channel image. We can run cell segmentation. We can then sequentially apply object classifiers for each of the different markers. We can then visualize the markers according using shapes and colors related to the combination of classes. Then we can query the spatial distribution of this kind of stuff. So there's lots of stuff already in there. We want to be able to improve that and also make it easier to use, because some of this will require some advanced scripting, but the software is designed to be able to support these kind of applications as they come. And that's what I mean by QuPath is sort of an application first. It's driven by research projects and collaborations, and then the range of applications that it can solve in a streamlined way hopefully will expand through these projects and grants. So if you want to get involved, join the user community. If you're not already there, image.sc is a fantastic place. I'm very happy that QuPath was able to be a part of it. There's now over 2,000 discussions there, somehow related to QuPath. It's hard to keep up with it, but there are some super users of the software who give fantastic answers. And often what I've learned is that I might have created it, but I'm no longer the expert in how to use it, because I learn from the stuff I read in the forum whenever other people come up with creative ways of applying QuPath. And so I find that quite exciting. So if you want to join in, join the forum, participate. You can ask your questions there, but also you can answer questions there, because it's fantastic help for an open source project if you don't leave answering the questions to maintainers. So I'm delighted when I see people answering questions there, and it helps a lot. You can follow me on Twitter as well, mostly because it's the place where I can make announcements of things. You can follow me or QuPath, it doesn't really make a difference because we say a lot of the same stuff. And you can join the team. And so the University of Edinburgh website has a link to the jobs at the moment. If you're watching this video at some later time, you can also check that website in case we have any new posts coming up. But there's going to be, there's 2 advertised at the moment. There'll be a few more. So please do check them out if you want to join me, because I think it's quite an exciting project. If you want to work in this area, we are a tiny team. Well, right now, I'm the only person developing it. So really the smallest team, but we will grow, and I'm looking forward to be able to work with hopefully 5 more people in addition to others working maybe not directly on QuPath but on image analysis applications. So the team is growing, but we have the ability to really shape the software together, and I really want to work with people who are excited about the possibilities there, and also we want to be good friends to the other software in the field. We're not out to compete with anyone, but we want to solve problems that can't be easily solved with other software and create something which is complementary. And with that, I just want to say thanks to a few people, in particularly Melvin, who sadly from my perspective has left. He's taken up a new position about a month or so ago, but he spent a couple of years working with me in QuPath in Edinburgh, and the software improved substantially during his time. He's massive help and incredibly helpful in the forum and in the code as well. Yvonne, who's my wife and has been patient with me throughout and is an immunologist, so she is illustrated here listening to me talk about it because I have been talking about it too much over the last years, but she also helps with the biological knowledge because I do not really have a lot of that. And apart from that, I hope I've thanked enough people. There are others. I've mentioned some of the super users and people who have been working on teaching the project as well. And thank you if you have listened to this workshop this far. And I will look forward to the I2K conference when it happens live. Thanks.